So today we do a presentation about how to connect Optitrack with Optitrack. So I installed the system for the tracking, and we'll see it later how to connect everything, and especially how to connect with the lens. Okay. So let's start with. I will start with few slides, and then I will move to the live presentation. And you can also ask any question at any time if you have some. Okay. So let's move to the slide. So I will do it quickly because you probably know a lot of it, but let's talk a bit about Optitrack. So yeah, as I said, first slide about Optitrack, then we will do the live demo, especially how to use Optitrack motifs, the cinepuck on top of the camera, and how to read the lens from the camera, and then some question if you want. Optitrack. So Optitrack is this small hub. So Optitrack itself is not a tracking technology, but it's more how to grab tracking data from other tech and unify everything in one stream of data. So especially spatial transformation while you are in space, this is what we get with Optitrack, and what is the lens is doing. The field of view, for instance, distortion, is it a big zoom, is it wide, stuff like that, okay? So you can use Optitrack for green screen, but you can also use it for LED, of course. So this is the first stage, the tracking, you know it, is the first step to get a good augmented reality experience. So we said augmented reality, but it's also virtual production, XR, there's a lot of names to talk about this, but it's the same technology at the beginning is the tracking data. Okay, so this is few feature about Optitrack, why it's important. So everything is a small device, a small box you plug to your network, so you can access to the Optitrack box through your favorite browser like Mozilla or Chrome. So it's based on IP. So as long as you have a network connection to the box, you can access to all the settings. So it means you can put the box close to the camera in the where is the shooting, and you can have the control room like far away and have access to the setting of the box. So this is one important features. Also, what is important is the connection with the lens. So we will see that a bit more further later. So you can have external encoders or direct linked with the lens. We have the synchronization, we have the time code, of course. And this, I already said it, it's over IP. So it means the data, the tracking is over IP, but you can also access to the setup over IP with a web app. And you can connect to the main broadcast render on the market. So zero density, of course, pixel-top axisymmetry is on VisRT, so the older, a bit older, and also Unreal directly. These guys, Unity, Ventoux, a bit less known. So we can connect to any render engine on the market because we deliver 3D tracking protocol. So it's like a standard protocol. So you can connect to anything. And we also released just few months ago a new protocol we developed. It's a TCD protocol. It's a bit like 3D, but with all the lens data inside also. I want to show you a small video because it's a bit more easy to understand what I just said. So this is the hub. And you can see you have some lens input, tracking inputs, sync input on the other side, network inputs. So use it, of course, you can use it on green screen, but also on LED, no problem about this. So at the beginning, when we started Optitrack, it was to use with a lighthouse technology coming from the VR industry, but we enhanced to be able to connect to any other device, and especially Optitrack. So you can see you can use it with your iPad if you are connected to the network. You have a connection with a lot of lens. If you don't have this kind of lens, you can also put an external encoders, a gear on the side to know what you are doing with the zoom. And then we provide a solution. It's like a calibration tool with this kind of board. I will show you it in live later to calibrate your lens. And then we output 3D protocol. So this is a tracking command protocol to go to any render engine on the market. All right. I go back to my slide. So as I said, you can make a combo with Optitrack box with any tracking technology. So SteamVR, anti-latency, Optitrack, or mechanical tracking. And today we will focus on Optitrack. So the good thing with Optitrack is depending on the numbers of camera you put on your studio, you can enhance the space for tracking, so you are not limited in space. And it's a fixed setup, so you do not have to recalibrate it every day. It's like when it's done, okay? Compared to other technology, for instance, Lighthouse, you have to recalibrate more often, and the space is more limited. So this is some image about Optitrack. So you can probably recognize your camera. So it's a prime X41 camera plus the Cinepuck. So the Cinepuck is on top of the camera, and then you track it with the X41 camera. So any prime camera, in fact, connected to Motiv can do the tracking for EasyTrack. And you can see on the bottom there is a small pelly case. This is the kind of pelly case you get when you buy a system. And then you have to connect the EasyTrack to the camera. Some words about the calibration software, but I will show you later. It's an additional software you can run on your computer in order to take some image pictures with the boards. So with this software, you can calibrate the lens. Calibrate the lens means you know exactly for each step of zoom and focus, what is the field of view, what is the distortion, nodal offset. So you know all the interesting parameters of your lens. So when you have it, the render engine can do the computer graphics elements that perfectly overlay with the video elements. So it's important when you have a lens to calibrate it in order to use it. Okay, about the lens also, I just put a slide to say we have a lot of lenses compatible with. So Canon Fujinon for broadcast. So this is the most used lenses in broadcast. So we just have to put a wire between the lens and EasyTrack, and then we can read the data of the zoom and the focus. And then we also have some compatibility with the cinema lens. For instance, Ingenieux and the Cooke /i protocol lens. So you can see on the side, this is an anamorphic lens from Cooke. The good thing about Cooke, it doesn't give you only the zoom and the focus. It also gives you all the parameters about the anamorphic distortion, stuff like that. So we have the protocol, so we can talk with this kind of lens. And for now, we are the only one to do that. And then you can also connect to some follow focus system. So I'm not sure you are very familiar with this kind of system, but when you do a movie, generally there is a guy who's in charge of the focus, and maybe another one in charge of the zoom, and they have some gear like remote control gear to control it. So we can connect to the system to know how much they zoom, how much they focus. And if you don't have any of this gear or any of these lenses, you can also put external encoders. I will show you external encoders. I have one of them here. So this is the kind of gear, you know. You attach this on the side of the lens, and then you can connect to know how much they turn the lens. I just want to show you that we have also some online documentation. So if I click here, yeah, we go to our website, and we have a very a short tutorial about how to connect Motiv with EasyTrack. So it's quite easy. I will show you later, or you can do it, but it means user can already have access to these tutorials. On this web page, you can see also we have a lot of video tutorials to so users are not lost when they want to use the system. They can find online some resources we provide to help them to install the system. So before to move to live demo, I make a slide like that. I suggest to have the network dedicated to the motion capture camera, the POU switch, okay? Yeah. Then you have an additional switch, an additional network dedicated for the tracking. So on top of the camera, you will see we attach the track box. We also attach the Cinepuck, okay? And also everything is synced. So we have synced to the track, synced to the camera. And there is also a sync to Motiv because we have the eSync box on the Optitrack system. So today I will use zero density for the demonstration, okay? Let's go to the live demo. So first I will start by, I will show the camera. Right. Okay, so here you can see you have the Cinepuck attached on top of the camera. So we use some rods bar, we attach it very rigidly on top of it, not so close to the camera in order to be sure there is no occlusion between the cameraman and the Optitrack camera. This is why I like to put some eye between the tracker and the camera. On the back, you can see there is an EasyTrack box attached to the camera. And there is one wire here, you can see here, plug on the lens port. So this cable is going from the box directly to the broadcast lenses. Okay, here. Okay. So it means we can talk to the lens, and each time we move something on the lens, EasyTrack know exactly how it has moved. Okay. It doesn't know what's the lens. It doesn't know right now the field of view or what does it means, but it know in percent how much the operator moves the focus, how much he moves the zoom. We also have the iris. Okay. If you don't have a broadcast lens like that, you can also put an external encoders. Okay. So we have the sync, and then so the box, there is a network cable. This is the black one here.
Black. Okay.
And the network cable is going to a switch, the main switch, and then they share the same network with the render engine and Motive. Okay. So I will put back the camera here. So this is Motive. You can see here Motive. So you can recognize there is 4 camera and there is a CinePuck. So this is an active LED markers. So you can like here. I put an offset to be at the center of the sensor of the camera. So it's a rigid body. And then when you have done that, you go to this panel. It's here, streaming. I will find it. Data streaming line. Okay, I can see it. You have to enable this broadcast frame data. And here you have to select the local interface where you want to broadcast the data. So today I have only one network that share camera and tracking, but it's better to have a separate network in a real configuration. Okay, so this is where you will select the right network. And on this switch, you also have to be connected to EasyTrack. So on this same switch, you connect Motive, plus you connect the link to the EasyTrack box. This is my EasyTrack. So you see, it's just like a website. You put the IP address, and you have access to EasyTrack. So this is EasyTrack. I can put in full screen. Yes, like that. So you have a live view in 3D of what's going on. And you can see I connect to Optitrack, and because Motive is enabled, we can see Motive as the IP address of Motive. So if I disconnect Motive, you can see it, but when Motive is enabled, you can see that. So you click here, and you have access to the rigid body. You have all the rigid body list here, and then you have to create like a tree of transforms, and you have to select transform Optitrack, and you have to select the CinePuck. And I will show you. So I will go back to the camera. So if I do a pan with the camera, for instance, I don't know if you can see it. In the 3D interface of EasyTrack, you can see it's moving in real time because Motive is streaming in real time the data to EasyTrack. So then when you have created your rig, then you have to select the protocol. So today it's 3D. You put the IP address of the render engine, port number, and you start. So now I have a 3D protocol streaming on the network. One more thing, I forget the lens. So you can see here, we connect the lens Canon. So you can see all the lens we can have access to. So today it's a Canon. So it's green. You can you have the name of the lens because it's recognized. It's a 14 by it's a 4.3 with a 14 zoom, and you can see here the zoom value. So if I zoom, this number should move. So I do a quick zoom, and you can see the number are moving up, moving down. Okay, but it will be better to see it when with augmented reality, of course. So we know where we are in space. We know what the lens is doing. We package the data together to do a 3D packet. Okay. The timecode is internal because today we do not provide a timecode to the box. It's an internal timecode when you don't provide any, but we provide a genlock. So you can see there is a genlock external on all the so Motive, the render engine, they share the same genlock. We have a genlock generator on the control room. But when you put a timecode, then you can set. So you have the choice to have a genlock plus a timecode, or if you only have a timecode, you can genlock by the timecode, the timecode. So you have choice.
Okay.
And okay, so this is all you have to know about Optitrack plus EasyTrack. But just a quick look in EasyTrack, you can see here, this is all the plugin we have for spatial transform. You can connect to EasyTrack. So Optitrack is here. And then you have a lot of panels, for instance, here with a lot of data. You have many settings you can adjust. It's here. When you have a template you have created you like, you can save it, and you can also load it. So it means next time you re-plug the box, you can load this template we just created with the right IP address and the right CinePuck device from Optitrack. So today I will use zero density because I like this one. So I will launch this project. I started to like 7 years ago to learn broadcast augmented reality with zero density, so I'm more confident with it. But pixel top is the same, maximetry is the same, so don't worry. Okay, so I load the here, and just to show you, so on zero density there is a kind of graph like that where you have to say, okay, this is my video card. Then here, this node, 3D node, this is a node where we connect the tracking, and you have to say, okay, my lens. So you can see here, I select the lens file I export from Easy Profile. Okay, so I can do some pan, tilt, and of course, if I zoom on my robot, you can see you have because we convert how much you turn the ring to a field of view, it's perfectly fits the robot inside the studio. So you can see your camera. You have 1, 2, we have 4 prime camera here, and we have the robot over there. And I also put because we are in zero density, so I know how to do that. I put some shadow on that follows the building here on the robot. So you can see, and the sync is perfect between Optitrack and the video.
Yeah.
Like that.
And if you zoom in, if you focus, then it would change the focus accordingly as well.
Yeah, this is a feature. It mainly depends of the render engine you use, but they have all it now, so it means you can have some blur like that, and you can also see the there is especially on broadcast lens when you change the focus. I will try to do it. There is some breathing of the lens. It's hard to see a bit. So I just changing the focus, and you can see the field of view is changing a bit. But because we calibrate it, the augmented reality is also changing a little bit the field of view. So the breathing is also applied to the augmented reality, like that. Yep. All right. So you can see like that, and I will try. It's a bit heavy, but because it's Optitrack, you can do any move. It's not pan and tilt, so you can also do this kind of move like that, like Steadicam move, especially.
And so you could go around the guy.
Yeah, of course.
Tracking.
Yeah, you can go around. So today it's augmented reality, but it's, as I said at the beginning, the exact same recipe is used on a green screen. It's exactly the same, and also in LED, it's exactly the same. So because we know where you are in space, you know what the lens is doing, so then you can do what you want with all this kind of setup, of course.